Hello, my name is Mike Driscoll, and today I'm going to talk about automating Excel with Python. So just a little bit about me and my background. I've been blogging about Python for more than 10 years, and I've been programming in Python for more than 15. I've written several books about Python, and I also like to do content creation online. So beyond blogging and writing books, I also tweet a lot about Python, and sometimes I do videos on my YouTube channel. Anyway, recently I released a book called Automating Excel with Python, and this particular talk is based loosely around my book. So let's get started by talking about some of the Python Excel packages that are out there. Python itself cannot open and read Excel spreadsheets all by itself. You need to install an external package. There are several popular ones. These are just a few of them. OpenPyXL or OpenPyXL is a very popular one. It can read and write Excel just fine, and it can do a lot of styling of the output as well. XlsxWriter only writes Excel documents, Excel spreadsheets, but it can also do styling and charts and all kinds of good stuff too, like OpenPyXL does. However, it cannot read them. There's some older libraries like XlrD and XlsxWriter. These were originally released for the old format, XLS files of Excel, like the 98 to 2000 version of Excel, before Xlsx became standard. I believe they've been upgraded to work with the new format, though, so these are also viable alternatives. Note that RD stands for read and WT stands for write. So if you want to read and write, you need both of those packages. XlWings is free, but they have like a paid support version, and I'm not sure or not whether the paid version also includes extra features. However, that one requires Excel to be installed to be able to use it. So if you want to use XlWings, make sure you also have a license of Excel and have it installed, or you won't be able to use it. These other ones do not require that. PyXL is paid only. And from the website, it says that you can basically, if you have this installed, you can basically use Python to script Excel like you would with VBA. So if you need that kind of integration with Excel, I would definitely check out this package. If you need slightly less integration with Excel, but more than these three packages provide, XlWings may be the one you want. If you want to check out a list of other tools, including some of the ones I mentioned, you can go to python-excel.org. It is kind of up to date with packages, but even it is missing some. Like I didn't talk about this one, PyXLSP or PyLiteXL, but there are even more that aren't even listed on here that use Excel, unless you use Excel with Python. For example, one of the most popular packages available right now for Python is called Pandas. And Pandas is used for data analysis and for scientific computing and data science. And it actually wraps OpenPyXL, XlrD, and XlsxWriter, and I think maybe even one more Excel package so that Pandas itself can read and write Excel documents. The problem being with Pandas is that while it wraps these to read and write, it doesn't actually wrap the charting or the cell styling parts of those packages. So if you want to make your reports look pretty, you can't do that with Pandas, but we'll talk about that some more later. For now, let's talk about OpenPyXL. OpenPyXL was the package I chose to write my book about, and it's what I'm going to mostly focus on in this talk. Reasons that I like it is that it's free and open source. It works even without Excel being installed. So if you happen to have a bunch of Windows users, they can create Excel documents. They can farm it out to your Linux server backend, and the Linux server can process those documents without needing another license of Excel installed on them, because Python doesn't care, or at least OpenPyXL doesn't care, and you can, just process them and load them up and do whatever data manipulation you need to, and then you can read and write the files back out again. And the reason I bring up the read and write multiple times is that OpenPyXL does both. Some of these packages do not do both. They only write or they only read. So OpenPyXL does both of those, which is super handy. If you want to install OpenPyXL, you can do python 3-m pip install OpenPyXL, and that'll install it to whatever your Python 3 is pointing at currently. So if you have Python 3.10 installed, and that's your default Python 3, it'll install OpenPyXL to Python 3.10. All right, let's look at a couple of different ways to read an Excel spreadsheet using OpenPyXL. The first way we'll use the load workbook function that you can import from OpenPyXL. So what that takes is the path to the Excel file that you want to load, and then it will load up worksheet names. Now let's go ahead and take a look at what I'm talking about here. So let's see, we want to load up books, XlsX. These are sheets. See these two tabs down here? These are both sheets. So what this code should do is it should print out the worksheet names. There should be two of them when it prints that out. Then it will grab the active sheet. Whichever one of these sheets is currently highlighted is considered the active sheet. I believe when I loaded this up, it said that sales was the active sheet. And if I did this correctly, it'll print out that sales is the title of that particular sheet. So if we run this code, it should print out the data for us. I might need to, there we go. So it shows a list with the worksheet names. It prints out the actual sheet object, worksheet sales, and then it prints out the title. So that worked the way I described. However, we didn't actually get like any of the data out of this Excel spreadsheet. All we got was titles and names of the worksheets. So let's learn how to grab actual cell data. So to do that, you can just grab the active sheet or choose the specific sheet programmatically. And then you just specify the cell coordinates, so A2, A3, and B3. So if we go back over here, you can see that A2 is this one, Python 101. A3 is WX Python recipes. And I believe you said B3, so B3 is 5. So if we run this code, it should still say that we're on the sales sheet, which it does. Python 101, WX Python recipes. And right here, we did something a little bit different. We assigned sheet B3 to a variable, which gives us a cell object in the OpenPyXL world. And that lets us just call cell.value. Instead of doing kind of this sheet A2.value, you can just create a cell instead. Makes things handier if you're looping over lots and lots of cells. Anyway, let's talk about reading a range of cells. So if you want to read a range of cells, you need to specify a range. And in Excel's world, you do that using in equations all the time by saying the start coordinate and the end coordinate, and then Excel will draw a box around those and start working with that particular data set. So in this case, we're going to go with A1 through B6. So let's go over here to A1 and B6, and I think this one we're going to go to sheet 1 book. So let's switch sheets and say A1 to B6. Oops. There we go. I think that's a merge cell. So we'll say this for now. Basically, you're grabbing A1 down here to B6. So it should grab all this data in these cells here. I think because this is a merge cell, it's not letting me select everything the way I want. All right, and that's why I have this code in here that when we loop over the cell range and for each cell in the column, if it is a merged cell, we're going to skip it. So this cell is going to get skipped because it's all merged together as one cell. That's why books is centered in this category. So when you run this code, it should print out a bunch of data. And you can see here that it printed out the labels, a column letter and row number, and then the value for each of those. And it grabbed A6 and B6, which were empty, so those returned to none. I think that's pretty handy myself. What if you want to read all of the data in all of the sheets that are included in your workbook? OpenPyXL makes that pretty simple, in my opinion anyway, because you can just say for sheet name and workbook.sheetnames, grab the sheet, doing workbook, and you notice it uses kind of a dictionary lookup here. Workbook sheet name, grab the title so we know which sheet we're grabbing data from, and then just loop over it using iter rows. You could use iter columns here too, and it would have the same effect. Either way, you're either looping over the rows or you're looping over the columns. In this case, I'm saying values only equals true, which should try to limit it to only grab cells that have data in them. And when you run this, you're going to get a bunch of data, and it's going to print them out as tuples. So there's a tuple of data, and there's a tuple of data, and you note it goes ahead and grabs some extra data from rows that don't have no data in it at all. I'm not entirely sure where it grabs, how it knows when to stop, because an Excel document could keep going for a really long time. But anyway, it stops after a little bit. I think there's like 20 rows here, maybe 30, and then it just stops. So this is a quick and dirty way to just read all the data out of an Excel document. All right, let's talk about creating Excel spreadsheets. So in this case, instead of reading, we're going to write one. You can create us an Excel spreadsheet with Python in 3 lines of code. From OpenPyXL, import workbook, create a workbook object, and then save it out. Now, that's not a very interesting spreadsheet, but it does create an empty one in just 3 lines of code. And you can tell it where to save it. For me, it's just going to save in the local namespace. But you could save it, in any user writable location on your machine. So since that's boring, let's go ahead and learn how to create sheets in our side of our workbook. So to create a sheet, you just call create sheet on your workbook object. So the reason that I'm doing this here is I'm going to print out that we have no worksheets yet. Then I'm going to add one. We'll print it out again to verify. Then we'll create another worksheet, and we'll specify the index to 1 and print it out again. So if we run this, you can see that when you first create it, there is a sheet, even though we didn't create one, because when you create a workbook, it has to have a sheet in it. So it does that automatically. When you call create, it creates sheet 1 in the second as the second sheet on the right. So if we switch over here, we do have sheet 1, and then we say create a third sheet, but we want it at index 1. Now when you do that, it puts the second sheet in between sheet and sheet 1. So this is how you can control the ordering. So let's say you made a mistake and you put the sheets in the wrong order. When you create the sheet, the next sheet, you can kind of reorder it by setting the index to the correct location. So again, we've created an empty worksheet or an empty workbook, but it has multiple sheets, but no data. So let's add some data. To add data, as you might expect, you still use the dictionary lookup, but instead of looking up, we're actually going to set values. So here, we grab the active workbook sheet and say that we want A1, A2, and A3 to be hello from OpenPyXL, and then we just save it out. Boom, we have hello Xlsx. Let's jump over here and grab this one. And you can see that those are the 3 values put into our little spreadsheet. All right. What if you want to delete data? OpenPyXL lets you do that too. So here, we're just going to create a workbook on the fly. We're going to add 6 cells worth of data, and then we're going to delete column 1, which is column A. Then we'll delete 2 rows starting on the second row, index 2, and for the amount means how many rows after that you're going to delete, so 2. So we'll delete 2 rows starting at index 2, and if you do that and run this code, you'll see that a lot of this data isn't there anymore. So let's go to deleting. And you'll see that from OpenPyXL is the only bit of data that is left. So B1 and C1 are no longer at B1 and C1. They're now A1 and B1 because everything else got deleted. So you can play around with that and just try it out, see what you can delete. You can delete sheets too if you need to delete the entire sheet. OpenPyXL just makes all this stuff easy to automate. All right, let's talk about cell styling. To style a cell, you can use built-in styles like title, headline 1, or headline 2. Let's run this and just see what it looks like. You can kind of get an idea of what I'm talking about here, if you actually see what I'm doing. So if I double-click this, you can see, let's go back to our code. So the first one is title. So this is a title case. And then we have headline 1 and headline 2. So headline 1, headline 2. If you look at the font size, you first see the first one, the title is 18. Headline 1 is 15 points, and this one is 13. So you kind of play with that to find out how you want your spreadsheet to look, and just use the built-in styles. Now, if the built-in styles aren't good enough for you, you can go ahead and create a named style. This is where you create a custom style all your own. So here, the styles and the colors in OpenPyXL are all done in HTMLX, or HTML, I mean. So use the HTML font colors or just colors in general, to create the colors. So this is like a red. We use font, which comes from openpyxl.styles. We're going to bold it and make the font size to be 22 points. We're going to create lines that are thicker than usual, so we can say thick. I believe you can do like a dotted line or a thin line. You can play with the different styles. You have to look at the documentation to figure that out. But you can also set the color of the sides too. And then each border has 4 sides. So you don't have to set I don't think you need to set them all up at once. You could just set left and right. But for this example, I'm going to set all 4 sides, left, right, top, and bottom, to the thick side style that I just added. And then at the very end, you create your name style using the name style class. In this case, we're going to give it a name called highlight. We'll pass our font object and our border object to it. And then at the end, we can add one cell with our name style and a couple of cells without any style names at all. So now when we go back to our spreadsheet, we can see what happens. So let's click off of that, and you can see here that the hello has thicker lines than these do. Not terribly thick, but they're red, and these are just kind of your generic sized font size and font type. All right. So fonts. You can do all kinds of different things with the fonts. You just have to make sure that you're using fonts that are installed on your computer. So you import font, you set the font size, you can set the font names, or Arial, or Tahoma, or Calibre, or whatever fonts you have included. You can set the color of the fonts to whatever colors you want. You can do all 3 or just a couple of those. And then when you run it, you can end up with a bunch of little neat looking code. So let's just grab that and we'll zoom in and take a look. So this one's red. This is Calibre by default. This one's Arial. And there's Tahoma. So just play around with that. You can make your spreadsheet look really cool just by playing with those colors. And you'll get to have a nice document that you can show off to your sales team or your manager. All right. So Excel accepts or can generate all kinds of different charts. Let's take a look at some of those charts that you can create. So for one example, what's super easy is the bar chart. The first thing you need for a bar chart is some data. So I just created a list of lists for data. And to add that data to my spreadsheet, you can just loop over the data and do sheet.append. And so these will go into like A1, A2, A3, B1, B2, B3, etc., into your spreadsheet. Now we have the data, and we want to create a bar chart. So to do that, you import you from openpyxl.chart, import your bar chart, your reference, and any other chart-related classes that you need. In this case, we're going to take the reference, and we're going to tell OpenPyXL what parts of the spreadsheet to grab data from. So first of all, we wanted to use the current worksheet, the active worksheet. Then we wanted to grab data from the minimum row 1 through 10, columns 2 and 3. Then we say bar chart dot add data to our reference, which is what data is. And then we're going to grab data from the titles that are in the spreadsheet. Finally, you add the chart to the spreadsheet, the current sheet that you have open, and you tell it where to start drawing, in this case, cell E2. So if you run this code and then jump over here, we can see how it ends up. Let's just zoom in a little bit. So what we're doing here is we're telling it to grab these two as our titles, which go into the legend. We're telling it to grab this data to create the chart. And bada bing, bada boom, you have a great little bar chart all done for you. Now what's cool is that it supports tons of other charts. So I have it here, it says see book code examples. That's over here in my little coding IDE. I have lots of different charts that I created for my book, but I'm not going to show you all of them because it's kind of boring to just jump through all these different charts. But there's like a bubble chart, a donut chart, line charts, area charts, pie charts, scatter charts, surface charts. There are just tons of them, and they're really cool. I think we should take a look at just a few of them though, just so you can kind of get a feel for what they're all like. All right, so one of my favorite charts is the surface chart. I just think it looks really, really neat. So if we run this code, I'm going to show you what we're going to do here. So first of all, it follows the same pattern that we looked at before. You create some data, you append it to the sheet, and then you create some charts. In this case, we're going to create a regular surface chart and a 3D surface chart. And so what we do is we create a chart with the same reference information that we did before, basically. And we add the data, and we tell it what kind of chart it is. This one's a contour, this one's a 2D, a surface, and a 3D. And then we just use Python's deep copy to create a copy of the data or the chart so we can create multiple charts, which makes things pretty slick, honestly. So if we go over here to our surface chart, let's take a look at this. So we're going to use this data set to create these 4 charts. Zoom in a little bit. Here's our contour chart, and you can see it kind of has this fake 2D or 3D look to it as it kind of pops out. And then you have the wireframe, and then you have this nice little surface chart in a 3D wireframe. Personally, I've always been interested in computer graphics and special effects, so being able to do something like this in Excel, it just looks cool to me. I don't know how much practical value it has, but I think it's really neat that you can do this with Python and Excel and in, kind of an office setting. So let's go ahead and look at a couple of others because they're just kind of fun to play with. I think the projected pie chart was kind of interesting. So let's go ahead and run that one. Now, as I recall, the projected pie chart kind of has like a pop-out chart to it, if I remember correctly. Yeah, it does. So it creates a chart and then like pops out a part of it and charts that as well. And I just think it's a really interesting way to display data. Now, personally, I'm not a data science person, so I'm not sure what kind of data you'd want to show with this particular type of chart, other than, you might want to show how something breaks up. You have like the majority of something is made with iron, and then you have like 40 smaller things, and you want to show that thing in a smaller chart. That's probably how you would do it using the projected pie chart. But I don't normally deal with data like that. So, use this as you see fit for your own project. But I just think that's a really neat way to show data. The other one I want to talk about is a donut chart, just because I think it's a neat shape. And it's not one that you see like every single day. So the donut chart looks like a pie chart, kind of with a hole in it. So let's just grab this one and take a quick look. So as you can see, it just creates this kind of a donut chart. And you kind of pop out the piece you're interested in. And you could also have like an inner chart inside of it. And I'm not sure if you can pop out the inner part too, but you can pop out parts of it. And it's just kind of a neat way to show data without making it look the same as like a regular pie chart. So it's just something you can play with, or you can just completely ignore this entirely. All right, I want to talk a little bit about Pandas and Excel. So if you've never used Pandas, you can go to pandas.pydata.org and go read about it and see what you do with it. The main thing you need to know is that Pandas is used for data science or for data analysis. So you can just load up Pandas, push a bunch of data into it, and then you could do like pivot tables, kind of. A pivot table in Excel is where you like pivot on certain parts of the data in your Excel file. And OpenPyXL doesn't really handle that. But you can take the data out of Excel and put it into Pandas, and then Panda can pivot it and do all kinds of data manipulation to it, and then you can put it back in again into Excel with Pandas or with OpenPyXL. I'm not going to show you how to do that, but I will show you how to create Excel with Pandas. So here we import Pandas as PD. I'm not sure who decided to start doing this, but this is the trend right now, is to do import Pandas as PD. Then they have this idea of a data frame object, which is kind of a list of lists for the data. You give it an index and a column, and then you can say df, or data frame, to Excel, and tell it where to write that Excel document. And you can tell it what sheet to write it on. So in this case, we're going to create a books sheet. Okay, 3 lines of code. Boom, you have data in an Excel spreadsheet from this really powerful library. And it's probably using OpenPyXL under the covers. I really can't tell how it decides which one to use. I think because it says Xlsx, it uses OpenPyXL here. But if I were to change this to XLS, I think it would switch and use XlwT to write the file out. But I'm not 100% sure. I've not traced it yet. Anyway, this is a really neat way to create the data. But what if you wanted to combine OpenPyXL and Pandas? There's a way to do that. OpenPyXL provides a way in its util submodule called DataFrame. So basically, data frames are how Pandas represents data internally, and lets you work with that data and analyze it. But it doesn't translate directly into something that OpenPyXL itself can use. So let's take that code from before, or just rewrite it. This stuff is pretty much the same as the previous code you saw. But here we have data frame to rows, which comes from OpenPyXL. And what it does is it takes the data frame in, and this you loop over it, just like we were doing with that list of lists in a couple of examples ago. So you can just go for row and data frame to rows, append it to the sheet, and you're done. So this is what I was talking about earlier. If you do a bunch of data analysis and data modification with Pandas, which is super duper fast, you can then output it back out to Excel using OpenPyXL. And because now it's an OpenPyXL, you can style it too, which is something that Pandas can't do. So by combining the two, you've kind of got yourself a superpower, and you can just do all the data analysis you want, and then you can make it look amazing for the business team so they can present your data to your clients as you need to. And style it however you want, or add charts to it with OpenPyXL. It's just kind of a win-win type of situation there. All right, other things that you can do with Pandas. Pandas lets you convert a CSV to Excel using, again, 3 or 4 lines of code. So in this case, I have a books CSV file containing the data we've looked at many times in this talk. You pass it to read Excel, which is the Pandas way of reading it in. I think you can specify, the separator and other little key bits of information about the CSV file, because not all CSV files are comma delimited. Some are space delimited or colon delimited or what have you. Anyway, it reads it in, turns it into a data frame. Now that we have it as a data frame, we can just say data frame to Excel, and boom, it's back out again. You just converted from a CSV to an Excel file in 2 lines of code right there. And if you wanted to put OpenPyXL in there, again, we can style the CSV file and make it look really pretty using OpenPyXL with Pandas. Super cool. All right, you can also plot with Pandas. Now this is completely different than plotting with Excel. What Pandas does is it hooks into a library called matplotlib, and lets you just plot the data. So you get yourself a data frame, and then you just say df.plot, and I think you can specify different types of plots and different ways to make it look prettier or not prettier. But we're just going to use df.plot and see what it looks like. Because I'm using Jupyter Notebook right here, it'll plot it directly below my code. You could also do this in IPython or something similar to that. And you can just run it in a presentation and show people, hey, I created this awesome data set. I worked with it. Now we can map it and show it off and plot it and help you see the trends. This is just a good way to present information to your business holders. All right, we're almost done. I just want to talk about XlsxWriter quick because it provides a couple of key features that are different than anything else that I've talked about with OpenPyXL. Okay, so let's get started with that. The pros and cons of XlsxWriter. It can do similar things as OpenPyXL when writing out, but it can only write out. It can't read Excel at all. So if you're going to use this, keep that in mind. You will not be able to feed an Excel file to XlsxWriter. It just does not do it. It only writes. But The cool thing about it is that it can do sparklines, which OpenPyXL cannot do. So I'll show you how what I even mean by a sparkline if you've never seen that before. It also does data validation, which is super cool. So let's check it out. First, by starting with creating an Excel document with XslxWriter. It's a mouthful. Even I'm having trouble saying it. Okay, so we import the module, which you do have to pip install, just like you do with Pandas and OpenPyXL. I didn't mention that earlier, but you do have to install all of these libraries to make them work. So to create a workbook, you use the module name .workbook and pass it the file path to the document that you want to create. Then you add a worksheet in much the same way as OpenPyXL. You can give it a name if you want. Create some data. And in this case, we're going to loop over it a little bit differently for book sales and data. It's going to grab each of these items out of this set of list items. And we're just going to do sheet.write, row, column, and then value. Row, column plus one value, etc. Add the worksheet to the workbook, and then close it. And that will create a really simple, really easy to use piece of data in a spreadsheet. But it's not very interesting. It does, well, actually, this example shows how. So data validation. Data validation, I like this example because it also shows how to format the data nicely in the spreadsheet using this different module. Okay, this stuff appears the same, creating our workbook, adding a worksheet. We set some columns up. Here is where the formatting comes in. The formatting is a dictionary, which is a little bit different than OpenPyXL. You can set the border, background color, whether the text is bold or not, whether the text will wrap or not, alignment, and indentation. And then, so we're going to call this is kind of like the name style that we created earlier. In this case, we're going to call this the header format. And so we're going to write directly to A1, here's the value, and here's the format style we're going to use. Then B1, something else, header format again. And what this data validation does is where it, well, actually here, I'll just show you. Sheet.data validation. This is going to make an Excel document that forces you to enter the right kind of value. So what we're going to do is we're going to validate that the user is entering an integer and that integer is between 1 and 15. And if they don't, an alert will pop up. So let's jump over back to our Finder and see how this code works. So validation.Xslx. We'll zoom in here. So here are those two values we were just talking about. The header stuff that we just created. Here is the cell that we're adding data validation to. And let's see let's see, 16. Let's see if that works. Hit enter, and it pops up an alert and says this value doesn't match the data validation restrictions defined for this cell. So we can hit retry, and let's try 12. That worked. Let's try entering some random letters. Again, it won't let us do that. And so we have to either hit cancel, and it'll return the value to what it was before, or you can hit retry and enter some value between 1 and 15. As far as I know, OpenPyXL doesn't provide that capability. And you know that you can do lots more data validation types than just what I'm showing here. But I just was like, this is a quick and dirty example that fits on my slide, and it shows exactly what I want to show off. And I just think it's really cool that you can do this with Python and create this way to force the user to kind of use a form inside of Excel. Will this have any practical effects for most people? Probably not, but it's just something that I think is neat. Okay, the other feature that I know OpenPyXL doesn't do is sparklines. What the heck is a sparkline? So a sparkline is a really tiny bar chart that fits inside of a cell. Now, what are these good for? I have yet to find any examples that actually tell me what in the heck these are good for. But I think they're really interesting. So let's just look at them anyway. Okay, here's the code. So, I always do that. Let's pop that back open. And you have your Spark styles here. So here we're going to say Sparky A1 to E1, A2 to E2, A3 to E3. So these are the ranges that the data will use to create the spark line. Then you have different kinds of markers. we have marker is true on this one. The type is column here, and the type here is win-loss. And this one, that's negative points happen. What does all this mean? Well, you have to run the code to find out what happens. So I think I've already run this, but I'll run it again just to make sure. But anyway, you loop through this data set right here, write the row out, add a spark line using the Spark styles that we created up here, and then you should have a nice little spreadsheet. Let's jump back over here and let's take a look. Alrighty. Then we'll zoom in so you can see what it looks like. So now we have a spark line. These 3 items are spark lines, and you see when I click on them, it shows you what data they are based off of. And you can just kind of see I think these are good if you have a really small data set and you don't want a giant spreadsheet. But beyond that, I don't think they'd be very useful, because the more data points you have, the smaller it's going to be and the harder it is to be able to read. And even now, I'm not entirely sure how useful this is, because I still had to zoom in to 273% to make it really visible what's going on here. Okay, I think I've reached the end of my talk. I just want to mention that now that you know how to use OpenPyXL to create great, awesome Excel documents, and you can use Pandas in combination with it, you could use other libraries inside Python to do other things. So, I've had a lot of experience doing extracting and transforming of data and then loading it into something else with Python. So you could take this information and combine it with other awesome libraries like ReportLab, which you might want to use to create a PDF. So you might load up the Excel document, do some formatting, grab the data, and then slap it into ReportLab, into a PDF using ReportLab. ReportLab can lay it out in a really nice way too, and then you have a PDF file. Or, you might want to extract the data from Excel and turn it into something that a web API could consume using Python's built-in JSON module. You have lots of options here. So just take this data and use it wisely. And I hope y'all post about it and tag me in it and let me know what cool things you've come up with that you can do with Python too. If you have any questions, you're free to ask me. Send me a post through my website, mouseversuspython.com, or you can leave a comment on whatever video format or whatever video places that you'll see this talk on. I'll see you later. Thanks for watching.